60 permutation sequence. So we are giving a set. So this set have numbers from 1 to n, and it's gonna have different permutations. And we want to return the case permutation with a number this n equals to some other positive integers. So for example, this integer is 3. So the case permutation, the third permutation, that is 2, 1, 3. As you can see that the permutation is in increasing order. So if it is numbers or if it is strings, it is always in increasing order, and the order is fixed. Yeah, but what we want to return the case permutation. So we can use two different ways to solve it. So the first way gonna be permutation. Let's just solve it in permutation. So let's prepare the nums. So the nums would be equal to list of range from 1 to n plus 1, and then we can use permutation to check that. Yeah, so let's prepare the result array. So the list of permutation of nums. Yeah. So after this permutation, actually it is in increasing order, and we need to know about that. This is just from the Python permutation library, and we can directly use it. Now, what about the answers? So the answers should be result k minus 1, and we need to turn the answers into a string. So the answers would be equal to string I. So for this item in answer, and finally we just need to join the answers array, and we're gonna get the result. Yeah, and this way is similar like seeding because we used the library. Yeah, but if you would like to write a backtracking function, you can also write it. So it is permutations, it is not permutation. Yeah, because it is a lot of subset, so we're gonna use permutations. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed, but it's quite slow. Now we want to optimize it because currently the time complexity is n times n factorial. Because the permutation of this n, so the time complexity is n times factorial n, so it's gonna be really slow. Now we want to optimize it, so the time complexity is O n times n factorial. So this is gonna be the time complexity. Yeah. Now we want to optimize it. So let's try to optimize the code. Let me just copy and paste it here and make a comment about it. Yeah. So if we want to optimize it, we can use the mathematics skills to solve it. Let's try to use the permutations from here. Yeah. So I want to use those 6 numbers. As you can see, there are 6 numbers like 1, 2, 3, 1, 3, 2. So the first number is 1, and for the second one it is 2, 1, 3, 2, 3, 1. So yeah, the first number also is the same, like 2 and 2. And you can check the third group, it's also 3. And if you were to check the factorial of 4, it's also the same. Yeah, but there will be just like 24 different strings. Yeah, but for factorial of 3, it is only 6, so I'm gonna use this example to analyze it because this is gonna be easier. Otherwise, I have to write 24 different cases. Now we're gonna use these 6 cases. Yeah, so in total they have different cases, but it's gonna be divided into 2, 2, and 2. Yeah, basically we're gonna use the mathematics skills to solve it. So we know that factorial of 3 is 6, but what about factorial of 2? It means after the first number, we're gonna check how many different permutations after the first number 1. So it's gonna be factorial of 2, 3 minus 1. So it's gonna have 2 different cases. Yeah, but we want to calculate the case permutation. So if the first group is not the case, we're gonna check the second group. So in this way, we're gonna check group by group. So it's gonna be really fast. Yeah, because from the beginning, this k equal to 3. So after the first group is 2, so this k would become 1. Yeah. So after the first group, definitely we are sure 1 is definitely we are sure the first number is not 1. Yeah, because the first group is excluded and the first number is 1, it's not possible. So 3 minus 2, so this k equal to 3 and the group number is 2, 3 minus 2, it is 1. So if this 1 is less than, yeah, so k is still 3, but our count, I'm gonna use another variable count. Yeah, so this k, yeah, let me use this count as a group. So count equal to 2. Yeah, so I have two variables. One is count. Count is the permutations of each group. So it's 2, 2, 2. So count is 2, and k equal to 3. Yeah. So for the first group, I'm gonna use this k minus count. So after k minus count, I get a number. It is 1. So it means it must be the first number in the second group. Yeah, because I have to check it like that. If it is the second and first number from the second group, so we are sure we're gonna pop 1 out of the string because we will not check 1 anymore. But yeah, how can let me explain it like this way. Yeah, because for the first number, definitely it's gonna be from the second group, because definitely it is not the first group. So the first number gonna be 2. Now we're gonna delete 2 from our string. So currently our string will be only 1 and 3. Yeah, because we are sure the first number must be 2. And for this 1 and 3, it's a new array. So for this new array, currently our k equals to 1. Yeah. So for 1 and 3, we still have some permutations. It's like 1, 3, and 3, 1. And for this permutation, we're gonna still check it. So what about the count? So the count is factorial, and it's gonna be factorial of it's gonna be 1. So the count gonna be the factorial of 1, because after 1 there's only one number, so the count gonna be 1, and currently this k is also 1. Yeah. So if this k yeah, so if this k is less than and equal to the count, so if this k is not more than count, so if this k is less than and equal than the count, basically this means we don't need to check the group anymore. It means we've already found it is the first group. Yeah, because from the beginning we got a string 2, and then we're gonna get a 1. After 1, we're gonna get a 3, and then we're gonna join them together. It's gonna be 2, 1, 3. Yeah. So basically, it's the mathematical idea. I think we have to check the code to make it yeah, easy to understand. And now let me just start coding. I'm gonna prepare a nums and result. So the nums are gonna still be the same from 1 to n. It's gonna be an array, and the result would be an empty string. And I don't need the permutations. I don't need here. Finally, I just need to return a result. Now I'm going to check all the possible numbers. So for I in so for I in range 1 to n plus 1, I'm gonna design it like 1 to n plus 1 because I'm gonna use this count. Actually, it is a group, a subgroup count. Yeah. So the count would be factorial of n minus I. So for example, for the first one, n minus 1. So if this so if n equal to 3, so n minus 1 it is 2, factorial of 2 it is 2. So for this testing case, so this is my first group. And I also need to prepare an index. It's going to be starting from 0. This will be determine which number inside of the nums array I need to take it out. So this is for the index. I will use this index to check the result. Now I'm going to check the count. If this count is more than, I'm going to check this k, because k should always, normally k should be more than the count. So I'm gonna update this k to minus the count, and if this is okay, it must be the next index. So the index would be plus 1. If it is still okay, the index would plus 1. So after the while loop, I can get the result would be plus equal to string of nums with index. And similarly, I also need to pop out this index. So the nums need to pop out the index. So after that, I need to return the result. Now let me check the code with the explanation from here. So this I is because that we're gonna use this factorial. For each of the subgroup, it will be n minus I. So for example, this n is 3, so the first subgroup, so this n minus I, it is 2. And for the next one, so n minus 0, n minus 1, 3 minus 1, it is a factorial of 2. And so first of all, it is 3 minus 1, it is factorial of 2, it is f2 should equal to 2. Now we have 3 minus 2, it's gonna be equal to f1. If it is f1, so the factorial of f1 is gonna be 1. And this index is used to check the nums inside of the nums array. So from the beginning, it is 1, 2, and 3. So first of all, it is at this position, it is at 1, because index is equal to 1. If this k is more than the group, the count, it means we're gonna check the next index, maybe it is 2. So this is why index plus 1 is gonna be 2. And the result would plus equal to this number, string nums index, it is 2. And then for this array, we're gonna pop out this 2. So it is the index 1. Now what we left behind, it is 1 and 3. So the problem becomes a subproblem. For the subproblem, we're gonna solve it exactly like the same. So it is similar like backtracking, but it's gonna be much faster because we use the iteration to solve the problem. Of course, it is much harder because it's really difficult to think about this kind of idea to solve the problem. Now let me run it to check. As you can see, it works. Now let me submit it to check. As you can see, it's really fast. It becomes 46 milliseconds. So this is why if we are going to test some testing cases, even this n gonna be really big. Maybe it is 25. We're gonna check 1,000th number. It's gonna still be okay. Let me just run it. Expected n to have values from 1 to 9, but as you can see that it is still okay. But we cannot put a larger value because this problem is designed to be 1 to 9, because there is only only valid number. The only number is only valid from 1 to 9. If you use a number 10, maybe it's not possible to solve such permutation problem. It has to be 1 to 9. But definitely this is going to be much faster. Now let's analyze the time complexity. And for here, this is n, because there are n numbers. And for here, this is also n, because it is like factorial of n. And here, we just use a while loop to check how many subfactorials, how many groups. So we're gonna check this is gonna be also n. So for each of the time, this will also be n. yeah, as you can see, the time complexity for this way will be n square. It is only n square. That is why it is so fast, because here is n, and this while loop, it is also n. Why? Let me use 4 factorial of 4 as an example. So for the while loop, maximum, maximum it's gonna be have 4 loops. So that is why it is also n. Yeah, I think that's it for this problem. Thank you for watching. See you next time.